The morning of October 8, 1943, dawned clear over occupied Europe. At 28,000 feet, Oberleutnant Hans Philipp led his formation of Focke-Wulf 190 fighters through thin, cold air. Below him, American B-17 bombers droned toward their targets, escorted by those massive American fighters the Luftwaffe had initially dismissed as too heavy, too slow, too awkward. Philipp was not a man given to dismissing threats. At 23 years old, he had flown over 500 combat missions. He wore the Knight's Cross with oak leaves and swords at his throat. He had shot down more than 200 enemy aircraft on 2 fronts. He understood air combat with the clarity that comes only from surviving when most do not. What he did not understand, what none of them truly understood yet, was what happened when 8 Browning M2 50-caliber machine guns converged their fire on a single point in space. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The P-47s came from above, diving, from 32,000 feet with the sun behind them. Philipp's wingman called the warning too late. The formation scattered. Philipp's engine began losing power at precisely the wrong altitude, the wrong moment, against the wrong opponent. An American pilot named Robert Johnson locked onto his tail. Johnson squeezed his trigger. All 8 guns fired simultaneously. 100 bullets per second erupted from the Thunderbolt's wings. The stream of fire, each round weighing 709 grains, traveling at nearly 2,900 feet per second, converged at a point 300 yards ahead of the aircraft. Philipp's Focke-Wulf flew directly into that convergence. The strikes ran along the fuselage like a zipper being pulled. Armor-piercing incendiary rounds punched through aluminum skin, through structural members, through the engine firewall. The aircraft exploded. No parachute emerged from the fireball. Johnson's combat report, filed hours later, was brief, clinical, the way young men learned to write about killing other young men. Sore hits along the body. Aircraft exploded. No parachute. Hans Philipp, who had survived 500 missions, who had mastered every aspect of aerial combat, who had destroyed more than 200 Allied aircraft, died in approximately 2 seconds. The 850 caliber machine guns of a single P-47 had converted a night of the air into vapor and falling wreckage. The news of Philipp's death rippled through the Luftwaffe like a shockwave through water. If Philipp could die, if 500 missions of experience meant nothing against those 8 guns, then what hope did anyone else have? The psychological impact was immediate and profound. German pilots began requesting transfers to other fronts. Some developed mysterious mechanical problems that kept them grounded. Others simply froze when they saw the distinctive shape of a thunderbolt, that massive radial cowling, those broad wings with 4 dark gun ports staring from each side like the eyes of a predator. This is the story of how 8 machine guns became more feared than the aircraft that carried them. This is the story of overwhelming firepower meeting tactical doctrine, of American industrial philosophy colliding with German aerial tradition. This is the story of why experienced Luftwaffe pilots, men who had mastered their craft, came to dread a specific combination of weapons more than any other threat in the sky. The journey to that October morning began 3 years earlier, in the offices of Republic Aviation in Farmingdale, New York, where engineers faced a fundamental question. How many guns does a fighter need? The answer, shaped by combat reports from Europe, shaped by American manufacturing capability, shaped by a philosophy that prioritized overwhelming firepower over elegant efficiency, would transform aerial warfare forever. In 1940, as the Battle of Britain raged across the English Channel, American military planners studied every combat report they could obtain. The reports revealed patterns. Fighter engagements were brief, measured in seconds rather than minutes. Most pilots never saw the aircraft that killed them. The majority of victories came from surprise attacks, brief firing opportunities, fleeting chances to pour bullets into an opponent before they could evade or return fire. The logical conclusion was stark. If you only had seconds to fire, if most encounters came down to a single burst, then you needed to put as many bullets into the target as possible in that brief window. European fighters typically carried 4 or 6 machine guns. The British Spitfire Mark V carried 8 .303 caliber Brownings, effective but relatively light. German fighters carried a mix of machine guns and cannon, prioritizing hitting power over volume of fire. The Americans looked at both approaches and chose neither. They would build a fighter that carried more guns than anyone else, firing ammunition more powerful than rifle-caliber weapons, creating a volume of fire that no other single-engine fighter could match. They would build a fighter with 8 50-caliber machine guns. The Browning M2 50-caliber machine gun was already legendary by 1940. Designed by John Moses Browning in the final days of World War I, it fired the 50 BMG cartridge, a round specifically developed to defeat armor. The full cartridge was 5.45 inches long, with a rimless, tapered case holding enough propellant to drive a 709-grain bullet at nearly 2,900 feet per second. The armor-piercing incendiary variant, the most common round loaded in aircraft guns, used a tungsten chrome steel core that could penetrate nearly an inch of face-hardened steel at close range. Even at 600 feet, the effective range of most air combat, the round could punch through nearly 0.83 inches of armor plate. The incendiary filler ignited on impact, useful for setting fire to fuel tanks and marking hits for the pilot. For aircraft use, Browning's design was modified into the AN M2 variant. The AN stood for Army-Navy, reflecting joint development. The aircraft version featured a substantially lighter 36-inch barrel compared to the 84-pound ground weapon, reducing weight to 61 pounds per gun. The shorter, lighter barrel had an unexpected benefit. It increased the cyclic rate of fire. Ground-based M2 guns fired at roughly 550 rounds per minute. The AN M2, cooled by the aircraft's slipstream rather than by heavy jackets, could fire between 750 and 850 rounds per minute. A single AN M2, firing at 800 rounds per minute, put 13 rounds downrange every second. 8 guns firing simultaneously put 104 rounds into the air every second. Over a 2-second burst, the standard firing duration for most combat encounters, a P-47 could deliver over 200 bullets weighing a combined 90 pounds. Republic Aviation's design team, led by Alexander Kartveli, had to build a fighter around these 8 guns. The challenge was immense. Each gun weighed 61 pounds. Each gun required ammunition, typically 425 rounds per gun in standard combat loading, stored in boxes behind the guns. Each gun needed feeding mechanisms, charging mechanisms, linkage ejection systems, and structural mounting points capable of withstanding the enormous recoil forces generated by 8 heavy machine guns firing simultaneously. The P-47's wing was engineered specifically to handle this armament. The main wing spars, forged aluminum members 4 inches thick at the center, were designed to carry not just the wing's weight and flight loads, but also the weight and recoil forces of the weapons system. The guns were mounted in a staggered arrangement, 4 per wing, to allow efficient ammunition feeding from separate boxes. The wing's internal structure created pathways for ammunition belts to feed smoothly without binding or jamming. The mounting system was itself an engineering achievement. Each gun had to maintain precise alignment despite vibration, temperature changes, and the violent recoil forces generated during firing. The harmonization process, where armorers adjusted each gun's mounting angle to ensure all 8 converged at a single point 300 yards ahead of the aircraft, required meticulous precision. Guns that weren't properly harmonized would spray bullets in a wide pattern, reducing effectiveness. Properly harmonized guns created a cone of fire that could obliterate anything in its path. German intelligence officers, analyzing photographs of captured P-47s, initially couldn't believe any fighter carried 8 heavy machine guns. The weight penalty seemed excessive. The ammunition requirement seemed impractical. The entire concept seemed to violate basic principles of fighter design, which emphasized maneuverability and climb rate over raw firepower. They were thinking about fighter combat the way it had been fought, The Americans were thinking about fighter combat the way it would be fought. The difference would prove decisive. The first P-47 Thunderbolts arrived in England in late 1942 and began combat operations in April 1943. German pilots initially viewed them with a mixture of curiosity and contempt. The massive fighters seemed ungainly compared to the sleek Messerschmitt Bf-109s and Focke-Wulf 190s. They climbed slowly, turned poorly at low altitude, and lacked the instant response of lighter fighters. Then the Americans started shooting. First Lieutenant Glenn Schlitz, flying with the 63rd Fighter Squadron, encountered approximately 20 Messerschmitt Bf-109s in January 1944. His flight attacked from altitude, diving with speed advantage. Schlitz locked onto the formation leader. He pressed his trigger. The 8 guns hammered. The Bf-109 exploded like a firecracker. The explosion was so violent, so immediate, that the wingman flying beside the leader simply froze, watching his commander disintegrate. Schlitz gave him a short burst. The wingman exploded identically. The formation scattered. Schlitz dove on another Bf-109 attacking a B-17, fired again, and again achieved an instant explosion. 3 fighters destroyed in less than a minute, all 3 exploding rather than smoking, burning, or limping away damaged. Pure catastrophic destruction. Schlitz later commented, with the dark humor of combat pilots, "I guess good old caliber 50 affects them all the same way." What affected them was not just kinetic energy. What affected them was the sheer volume of fire, the mathematical certainty that when 8 guns converged, something in the target aircraft would fail catastrophically. The ammunition loading made the difference. American armorers typically loaded mixed belts, ball rounds for general effect, armor-piercing rounds to penetrate structural components and engine blocks, armor-piercing incendiary rounds to penetrate and ignite, tracer rounds, typically every 5th round, to mark the stream of fire and allow pilots to adjust aim. The incendiary rounds, burning at nearly 3,000 degrees Fahrenheit, would melt aluminum airframe components instantly upon contact. When 100 bullets per second, including 20 incendiary rounds per second, struck an aircraft, multiple things happened simultaneously. Structural members were severed, control cables were cut, fuel lines were punctured, and critically, fuel tanks were ignited. German fighters, carrying fuel in wings and fuselage tanks, had self-sealing systems, but those systems required time to work, seconds for the rubber lining to swell and close holes. The P-47 didn't give them seconds. The volume of fire was so intense that multiple hits would occur before the sealing compound could react, and the incendiary content made ignition nearly certain. German pilots reported a terrifying pattern. When hit by P-47 fire, their aircraft didn't gradually fail. They exploded. Instantly. Completely. No warning, no time to bail out, just a flash and oblivion. The psychological impact was devastating. In fighter combat, pilots learned to recognize damage states. You could feel an engine losing power, feel controls becoming sluggish, feel the aircraft telling you it was time to disengage or bail out. Against the Thunderbolt's 8 guns, there was no warning. You were flying, then you were dying, with nothing in between. The technical explanation lay in convergence patterns and target vulnerability. The 8 guns were harmonized to converge at approximately 300 yards, though. Some pilots preferred closer or farther convergence, depending on their tactics. At the convergence point, all 8 streams of fire occupied a space roughly 6 feet across. An aircraft flying through that space would receive hits across its entire fuselage width simultaneously. Consider the anatomy of a German fighter. The Bf-109G, the most common variant by 1943, was approximately 29 feet long with a wingspan of 32 feet. The fuselage was perhaps 5 feet wide at its widest point. When 8 streams of 50 caliber fire, each stream delivering 13 bullets per second, converged on that fuselage, the mathematical probability of hitting critical components approached certainty. The engine would take hits, the cockpit area would take hits, the fuel system would take hits, The control surfaces would take hits, all simultaneously. The cumulative damage wasn't additive, it was multiplicative. One fuel line punctured could be survived. 6. Fuel lines punctured simultaneously, with incendiary rounds igniting the leaking fuel, could not be survived. German pilots adapted their tactics. They were trained to attack bomber formations from head-on, flying through the bomber's defensive fire to get shots at cockpits and engines. Against P-47s, head-on attacks became suicidal. The combined firepower of 8 50 caliber guns, all firing forward, created a cone of fire that filled the approach corridor. German fighters attempting head-on passes found themselves flying into an impenetrable wall of bullets. Oberst Johannes Steinhoff, who survived the war with 176 victories, described the experience in his memoir. Approaching a thunderbolt head-on was like flying into a firestorm. You could see the muzzle flashes, like someone firing 8 small cannons simultaneously. Then the tracers, streams of light converging ahead of them. If you continued the attack, you flew into that convergence. Most who did so died instantly. Those who broke off early survived but lost their attack opportunity. The Germans tried deflection shooting, approaching from angles that would minimize exposure to the Thunderbolt's forward firepower. This worked occasionally, but deflection shots were difficult, requiring precise timing and aim to lead a fast-moving target. And the P-47 pilots were learning. They were learning to use their speed advantage, gained from the massive Pratt & Whitney R2800 engine and sophisticated turbocharger system, to control engagement geometry. The American pilots developed a simple tactic: climb to 30,000 feet or higher, where the P-47's turbocharged engine produced full power, while German engines gasped for air. Wait for the enemy. When they appeared below, dive. Accelerate past 500 miles per hour in the dive, faster than any German fighter could follow without risking structural failure. Close to firing range. Trigger the 8 guns. 2-second burst. Then extend away using excess speed to break contact before the enemy could respond. If the target exploded, excellent. If the target evaded, climb back to altitude and repeat. The P-47 pilot controlled when to fight and when to disengage. The German pilot could only react, always defensive, always trying to survive until the American ran out of ammunition or fuel. The ammunition supply gave the Americans another advantage. Standard combat loading was 3,400 rounds total, 425 rounds per gun. At 800 rounds per minute per gun, that provided approximately 32 seconds of continuous fire. In practice, pilots fired in 1 to 2 second bursts to conserve ammunition and maintain gun barrels within temperature limits. This allowed 15 to 30 separate firing opportunities per mission. German fighters carried far less. A Focke-Wulf 198, considered heavily armed, carried 4 20mm MG151 cannons with approximately 250 rounds total, and 2 13mm MG131 machine guns, with approximately 475 rounds per gun. The cannons, firing at approximately 700 rounds per minute, would empty their magazines in approximately 20 seconds of continuous fire. In practice, firing all weapons simultaneously, a German pilot had approximately 5 seconds of ammunition. The Americans could fire for 32 seconds. The Germans could fire for 5 seconds. The Americans could afford to make mistakes, to fire at long range, to walk their fire onto target with multiple bursts. The Germans had to make every burst count, conserve ammunition obsessively, disengage after expending their limited supply. The psychological burden of limited ammunition affected German aggressiveness. Pilots who knew they only had seconds of fire became cautious, hesitant, reluctant to commit to attacks that might waste precious ammunition. The reliability of the Browning M2 added another dimension to German frustration. German 20mm cannons, particularly the MG151 and the more powerful MG152, were devastatingly effective when they worked. A single 20mm high-explosive round could destroy critical components or sever structural members. But the German cannons jammed frequently, particularly in the cold temperatures of high-altitude combat and under the stress of high-G maneuvers. German pilots reported jam rates approaching 15% per sortie for cannon armament. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. A jammed cannon in combat was worse than no cannon at all. It meant the pilot had expended ammunition without effect, reduced firepower for the remainder of the mission, and often required dangerous procedures to clear the jam while under enemy fire. Some pilots, experiencing repeated jams, lost confidence in their weapons entirely, hesitating to fire because they expected failure. The American 50 caliber guns rarely jammed. The AN M2 was designed with reliability as a primary goal. The simple recoil operation, proven over decades of development, functioned consistently even under extreme conditions. The guns were regularly maintained by skilled armorers who understood the weapon's quirks and potential failure modes. American pilots expected their guns to function every time they pressed the trigger. German pilots hoped their guns would function. This reliability translated into tactical confidence. American pilots could commit to attacks knowing their weapons would work. German pilots committed to attacks knowing their weapons might fail at the critical moment. The psychological difference was enormous. Confidence allows aggression, doubt breeds hesitation, and in air combat, hesitation is fatal. The devastating effectiveness of the 850 caliber guns became legendary through specific incidents that spread through both American and German pilot communities. These stories, repeated and elaborated, took on mythic qualities, but the core facts remained verifiable through combat reports and post-war interviews. Captain Francis Gabreski, who would end the war as the top-scoring American ace in Europe with 28 victories, perfected techniques for employing the P-47s' firepower. Gabreski, son of Polish immigrants, flew with personal intensity, viewing every mission as revenge for Nazi occupation of his ancestral homeland. His tactics exploited the Thunderbolt's advantages ruthlessly. Gabreski would position himself above German formations, between the enemy and the sun. He would watch for the moment when German fighters committed to attacking bombers, the moment when they were focused forward, unable to check their 6 o'clock. Then he would dive, accelerating to maximum speed, closing to point-blank range before firing. His rule was simple. Get close enough to guarantee hits, fire a concentrated burst from all 8 guns, observe the result, and immediately extend away before anyone could react. His kill-to-ammunition ratio was extraordinary. Gabreski averaged approximately 300 rounds expended per confirmed victory, meaning he destroyed 1 aircraft for every 3 seconds of fire from his 8 guns. The standard for the period was approximately 1,000 rounds per victory. Gabreski achieved 3 times the efficiency of average pilots because he understood that at close range, with properly harmonized guns, even a brief burst from 850s would cause catastrophic damage. Other pilots reported similar patterns. When they closed to within 200 yards and fired, German aircraft disintegrated. One pilot described hitting a Messerschmitt Bf 109 from close range and seeing the pilot's body severed before it fell from the disintegrating aircraft. The sheer concentration of fire at close range was too much for any aircraft today to withstand. German pilots developed specific warnings about engaging Thunderbolts. Luftwaffe tactical directives from late 1943, captured after the war, explicitly warned pilots to avoid extended combat with P-47s, to fire only at close range where accuracy was guaranteed, and to disengage immediately after the first attack pass, regardless of results. These directives, written by experienced commanders who understood tactical realities, represented an admission of defeat. The Luftwaffe was telling its pilots to avoid fighting American fighters, not because German aircraft were inferior in performance, not because German pilots lacked skill, but because the combination of American firepower, American tactics, and American aircraft survivability made extended combat a losing proposition. The 850 caliber guns had created a tactical asymmetry that couldn't be overcome with maneuverability or speed alone. Major Joseph Priller, a highly experienced Luftwaffe pilot who commanded Jagdgeschwader 26, one of the elite fighter wings, made a statement after the war that captured the German perspective perfectly. "We laughed at them in 1943. Nobody laughs now." He elaborated, noting that the Thunderbolt's guns never jammed, never overheated despite extended firing, and delivered firepower that exceeded expectations consistently. The never overheated observation requires context. The guns could overheat if fired continuously, which is why pilots were trained to limit burst length. But the air-cooled design, combined with the cooling effect of high-speed flight, meant that in typical combat usage, firing in 1 to 2 second bursts with intervals between, the guns remained within acceptable temperature ranges. German cannons, with their more complex mechanisms and higher chamber pressures, were more sensitive to heat-related failures. Priller's comment about laughing revealed the initial German assessment. When the P-47 first appeared, German pilots viewed it as a joke, too heavy, too unwieldy, clearly designed by engineers who didn't understand fighter aviation. By 1945, that joke had killed thousands of Luftwaffe pilots. The respect, grudging and bitter, was universal among German survivors. The ground attack role revealed another dimension of the 8-gun armament. As Allied forces advanced after D-Day in June 1944, P-47 groups increasingly focused on close air support and interdiction missions. Pilots would escort bombers to targets, then drop to low altitude on the return flight and strafe targets of opportunity. Trains, trucks, tanks, artillery positions, troop columns all became targets for the Thunderbolt's guns. The 50-caliber armor-piercing rounds, designed to penetrate aircraft armor, proved equally effective against light vehicles and equipment. A 2-second burst from 8 guns delivered 200 rounds. Against a German truck convoy, that burst would shred multiple vehicles. Pilots reported the violence of the impacts, how armored vehicles would literally be knocked sideways by the concentrated fire, how locomotives would explode when rounds penetrated boilers, how trains would derail when rounds cut through rail beds. German ground forces learned to recognize the sound of a P-47's Pratt & Whitney radial engine, that distinctive throaty roar that was different from the high-pitched scream of inline engines. They called the Thunderbolt Jabos, short for jagged bomber or fighter bomber, but the term carried dread rather than simple description. When they heard that sound, they scrambled for cover, knowing that 8 50-caliber guns were about to rake their positions. Second Lieutenant Cliff Sari, flying with the 378th Fighter Squadron, 362nd Fighter Group, experienced the ground attack mission's dangers firsthand on November 20th, 1944. His flight had already destroyed 20 rail cars and 2 locomotives by skipping bombs into a tunnel entrance. Flying south seeking additional targets, they spotted 9 trucks on a road near Saarguimund. Sari's flight leader ordered the attack. Sari checked his 8 guns, verified his gun sight was functioning, and rolled into the strafing run. As he lined up the trucks in his sight and prepared to fire, a German 20mm or 37mm anti-aircraft shell struck his engine cowling. The shell penetrated the cowling side, destroyed several cylinders of the massive radial engine, and ruptured oil lines. Hot engine oil sprayed across the windscreen, coating it completely. Sari had 0 forward visibility. Any other fighter would have been finished. The pilot would bail out or attempt a forced landing in enemy territory. Sari had a P-47. The enormous R-2800 engine, even with multiple cylinders destroyed, continued running. Sari couldn't and see forward, but his instruments functioned. He pulled up from the attack, formed up with his wingman who talked him through the climb, and set course for base. For 50 minutes, Sari flew on instruments alone, unable to see anything ahead. His wingman provided navigation guidance. As they approached the base, Sari faced the landing. He couldn't see the runway. The oil coating was too thick to see through. So he tightened his goggle strap, opened the cockpit canopy, and stuck his head out into the 300-mile-per-hour slipstream, using peripheral vision to align with the runway. He landed successfully. When he shut down and climbed out, He slipped on the oil-coated wing and fell to the ground in a heap. The ground crew stared at his aircraft. The entire fuselage and inner wing sections were covered in a thin, dripping layer of oil. The engine cowling had a massive hole. Multiple cylinders were destroyed. The aircraft was declared beyond economical repair, but Sari walked away without injury. He completed 80 combat missions in P-47s, attributing his survival to the aircraft's ruggedness and firepower. The combination of survivability and firepower created a tactical advantage that German pilots simply couldn't counter. They might damage a Thunderbolt, but the aircraft would likely make it home. Meanwhile, if the Thunderbolt's 8 guns landed hits, the German fighter would likely explode. The mathematics were brutal. Trade shots with a P-47, and you would probably die while your opponent probably survived. This asymmetry forced German pilots into defensive tactics that reduced their effectiveness. The late war period brought new challenges that highlighted the 8-gun armament's versatility. By late 1944, Germany had introduced the Messerschmitt Me-262 jet fighter, the world's first operational jet fighter aircraft. The Me-262 could reach speeds exceeding 540 miles per hour, far faster than any Allied piston engine fighter could sustain in level flight. The jet's speed made conventional interception tactics impossible. By the time a pilot recognized the threat and maneuvered to engage, the jet would be miles away. American commanders worried that the new jets would devastate bomber formations. The P-47 groups developed specific anti-jet tactics that exploited the one advantage they retained: firepower. The Me-262, for all its speed, was vulnerable during takeoff and landing, when it operated at low speeds with limited maneuverability. It was also vulnerable when it committed to attacking bombers, when it had to slow down and stabilize its flight path to aim its 30mm cannons. American pilots learned to position themselves near known jet bases, waiting for the vulnerable moments. The 56th Fighter Group, the top-scoring P-47 unit in Europe, received specially modified P-47M models in early 1945. These aircraft featured upgraded engines producing 2,600 horsepower with water methanol injection, allowing speeds approaching 460 miles per hour at altitude. More importantly, they received special T-48 50 caliber incendiary rounds developed specifically to ignite jet fuel, which has a higher ignition temperature than aviation gasoline. The new rounds, manufactured at the Des Moines Ordnance Plant, contained 5.4 ounces of incendiary composite, twice the quantity in standard Moni incendiary rounds. When these rounds struck an Me-262's fuel tanks or engines, the jet would burn with spectacular intensity. Air Force reports noted that enemy aircraft hit with the new ammunition would burn after being struck only 2 or 3 times. One pilot destroyed 10 aircraft in a single mission by firing short bursts at a German airfield. Captain John Fahringer, flying Devastatin Deb, engaged an Me-262 over Regensburg on April 5, 1945. The jet had just destroyed a B-17 with its heavy cannon, streaking through the bomber formation at over 500 miles per hour before peeling away at 9 o'clock. Fahringer and his fellow P-47 pilots jettisoned their external fuel tanks and dove in pursuit. The jet pilot made a critical mistake. He tightened his turn, probably trying to line up another bomber attack. The turn scrubbed off speed, allowing Fahringer to close within range. At 500 yards, he opened fire with all 8 guns loaded with the special incendiary ammunition. The smoke began pouring from the jet. Then something fell past Fahringer's right wing. It was the German pilot, ejecting from his dying aircraft. The Me-262 crashed in flames. The 850 calibers had killed the future. Between March and April 1945, the 56th Fighter Group claimed 15 jet aircraft destroyed, at least 7 of which were Me-262s. Not one P-47M was lost to enemy fighters in air-to-air combat, though 12 were lost in accidents due to the modified engine's reliability problems. The jets were faster, more advanced, representing the cutting edge of aviation technology. The P-47's 8 guns were a comparatively simple weapon system, essentially World War I technology scaled up and multiplied. But the simple solution worked. The ground strafing campaign in the final months of the war demonstrated the 8-gun armament's devastating effectiveness against ground targets. P-47 groups roamed across Germany, attacking anything that moved. Their guns destroyed approximately 9,000 locomotives, 86,000 railroad cars, and 6,000 armoured vehicles. The actual numbers are likely higher, as many damaged vehicles were abandoned and not counted in official tallies. Major Walter Motzenbecker, leading a squadron from the 365th Fighter Group, the Hell Hawks, caught a German convoy in the open near Metz in late 1944. His 16 P-47s trapped approximately 50 trucks before they could reach cover. The squadron attacked in flights, creating a crossfire with their 128 50 caliber guns firing simultaneously. The results were catastrophic for the German convoy. The armor-piercing rounds blasted trucks completely off the road and into ditches. Fuel tanks exploded. Ammunition trucks detonated. Within minutes, the road was a smoking ruin. Motzenbecker then led his squadron down side roads, hunting for additional targets. They found a platoon of tanks under trees and dive-bombed them until the panzers disappeared in smoke and flame. What had begun as a chance encounter developed into a marathon air-ground battle. The 16 P-47s, with their combined firepower of 128 50 caliber guns and several thousand pounds of bombs, effectively destroyed an entire German unit. The survivors scattered into the woods. The unit ceased to exist as an effective fighting force, and the P-47s returned to base, most with battle damage, but all with their pilots alive. The cumulative effect of this firepower, applied consistently over months, devastated German logistics and mobility. Trains couldn't move in daylight. Truck convoys were slaughtered. Supply lines collapsed. German ground forces went hungry, ran short of ammunition, lacked fuel for their vehicles. The 8 guns of individual P-47s, multiplied across dozens of fighter groups, thousands of sorties, millions of rounds expended, destroyed Germany's ability to sustain military operations. Field Marshal Hermann Göring, commander of the Luftwaffe, reportedly stated after the war, "If the German Air Force had the Browning 50 caliber, the Battle of Britain would have turned out differently." The statement, whether accurately attributed or apocryphal, captures the German recognition that American firepower philosophy had proven superior. German fighters carried cannons that delivered more explosive force per round, but fired fewer rounds and jammed more frequently. American fighters carried machine guns that delivered less force per round, but fired many more rounds with extraordinary reliability. The German approach assumed that quality would overcome quantity, that well-trained pilots with superior weapons could defeat numerically superior forces. The American approach assumed that overwhelming firepower, consistently applied, would grind down any opposition regardless of individual quality. World War II proved the American assumption correct, not because German pilots lacked skill or courage, not because German aircraft lacked performance, but because the cumulative effect of thousands of American fighters, each carrying 8 reliable 50 caliber guns, each pilot confident in their weapons, each squadron capable of sustained operations, created a tactical environment that German forces simply couldn't survive. The post-war analysis of aerial combat revealed statistical patterns that validated the 8-gun configuration. The P-47's kill ratio, the number of enemy aircraft destroyed per P-47 lost in air combat, exceeded 4-1. This meant that for every Thunderbolt shot down by enemy fighters, more than 4 German aircraft were destroyed. The ratio was higher than most contemporary fighters, including the more maneuverable P-51 Mustang. The reason came down to firepower and survivability working in combination. The P-47 could absorb damage and continue fighting, giving pilots multiple chances to employ their weapons. When those weapons hit, they destroyed targets with high probability. The German fighters, more fragile and carrying less ammunition, had fewer chances to score kills before being forced to disengage. The cumulative advantage, compounded over thousands of engagements, produced the statistical disparity. Individual German pilots who survived the war and were interviewed decades later consistently mentioned the P-47's guns as the most terrifying aspect of the aircraft. Not the speed, not the dive performance, not the armor protection. The guns. The knowledge that if those 8 weapons achieved a concentrated burst, you would die before you could react. The psychological impact of facing that threat, mission after mission, wore down even the most experienced pilots. Oberst Johannes Steinhoff, in his memoir, wrote about the psychological burden of flying against American fighters. We learned to respect all our opponents, the Russian pilots for their courage, the British for their determination, the Americans for their numbers. But we feared the P-47 specifically. It represented American industrial might in tangible form. 8 heavy machine guns that never failed, thousands of rounds of ammunition, pilots who could afford to be aggressive because their aircraft would bring them home. It was psychological warfare. We knew that one mistake, one moment of inattention, and those 8 guns would find us. And when they did, we would not survive. The technical superiority of American manufacturing played a crucial role in the 8-gun system's effectiveness. Each AN-2 machine gun was built to precise specifications using modern mass production techniques. Components were interchangeable between weapons. Armorers could swap parts between guns in the field, maintaining high operational readiness rates. The ammunition was manufactured to equally precise standards, ensuring reliable feeding and consistent ballistics. German weapons manufacturing, stressed by Allied bombing and resource shortages, couldn't maintain the same quality standards. German cannons were hand-fitted, with components requiring individual adjustment. Ammunition quality varied between factories and production runs. The result was lower reliability in the field, which translated to reduced confidence among pilots and lower combat effectiveness. The American system worked because it was designed as a complete system, not just a collection of individual components. The guns, the ammunition, the aircraft structure, the harmonization procedures, the maintenance protocols, the training curriculum, everything fit together to produce a weapons system that functioned reliably under combat conditions. That systems engineering approach, characteristic of American industrial philosophy, gave the P-47 an advantage that went beyond raw specifications. The human cost of the air war makes the P-47's firepower even more significant. Approximately 26,000 American airmen died in combat over Europe during World War II. P-47 pilots had the lowest combat fatality rate of American fighter pilots, approximately 12% over a full combat tour. This compared to 18% for P-38 pilots and approximately 20% for heavy bomber crews. The 850 caliber guns contributed to this survival rate indirectly. Pilots who knew their weapons were devastatingly effective could engage with confidence, could press attacks aggressively, could destroy threats before those threats could fire back. Defensive mindsets, hesitation, caution born of uncertain weapons, all increased vulnerability. Offensive mindsets, aggressive engagement, confidence born of reliable weapons, all increased survival probability. Every P-47 pilot who survived the war owed their life to multiple factors: the aircraft's structural strength, the armor protection, the reliable engine, the training they received, the tactics their squadrons developed, but they also owed their lives to 8 Browning M2 machine guns that fired when the trigger was pressed, that hit where the sight was aimed, that destroyed what they hit. Colonel Hubert Zemke, who commanded the 56th Fighter Group, the top-scoring P-47 unit with over 600 aerial victories, spoke at a 1961 reunion of former Thunderbolt pilots. His words captured what the 8 guns meant to the men who flew with them. We didn't fly the fastest fighter. We didn't fly the most maneuverable fighter. We didn't fly the prettiest fighter. We flew the fighter that brought us home. When you're 23 years old, 6 miles above Germany with the Luftwaffe shooting at you, that's all that matters. The Thunderbolt was built by people who understood that. It was built by people who cared whether we lived or died. Every one of us in this room owes our life to the men and women who designed and built that aircraft. They gave us protection when we needed it most. They gave us a fighting chance when the odds were against us. They gave us the confidence to press the attack because we knew, no matter what happened, the jug would get us home, and they gave us 8 50 caliber machine guns that never failed. The reunion attendees, over 2,000 former P-47 pilots, understood exactly what Zemke meant. They had felt the aircraft shudder when all 8 guns fired simultaneously. They had seen enemy fighters explode under concentrated fire. They had landed at base with battle damage that should have been fatal, climbing out alive because their aircraft refused to quit. The 8 guns were part of that complete package, the weapons system that let them fight with confidence, that let them dominate the air over Germany, that let them come home to their families. The legacy of the 8-gun armament extended far beyond World War II. The United States Air Force, analyzing combat data from the war and later from Korea, concluded that firepower concentration was more important than individual projectile lethality for air-to-air combat. This philosophy influenced fighter design for decades. The F-86 Sabre, which fought over Korea, carried 6 50 caliber guns, and later variants increased the rate of fire to over 1,000 rounds per minute per gun, using the M3 model Browning. Even as cannon armament became more common in the 1950s and 60s, the lesson remained. Multiple reliable weapons firing in concentration were more effective than fewer, more powerful weapons that fired more slowly or less reliably. The Aton Thunderbolt II, developed in the 1970s specifically for close air support and named explicitly in honor of the P-47, carried the GAU-8 Avenger, a 7-barrel 30mm rotary cannon that fired 65 rounds per second. The design philosophy echoed directly back to the P-47. Overwhelming volume of fire, devastating effect on target, reliability above all else. Modern fighter aircraft, equipped with missiles and sophisticated avionics, still carry guns for close-range combat. The 15 Eagle, F-16 Fighting Falcon, F-18 Hornet, all carry 20mm rotary cannons based on the same principles John Browning established with the M2. High rate of fire, reliable operation, sufficient ammunition for multiple engagements. The technology evolved, but the philosophy remained unchanged. The German aces who survived the war and spoke honestly about their experiences consistently acknowledged one truth. The P-47's 850 caliber machine guns represented the most formidable fighter armament they faced. Not because the guns were individually superior to German cannon, but because there were 8 of them, because they worked reliably, because they were backed by thousands of rounds of ammunition, because the pilots who aimed them had the confidence to press attacks until the target was destroyed. That combination, firepower plus reliability plus volume plus confidence, created a weapons system that German pilots learned to fear above all others. They could respect the P-51's speed and range. They could respect the Spitfire's maneuverability. But they feared the P-47's guns, those 8 Browning M2s that turned brief encounters into catastrophic defeats, that exploded fighters in mid-air, that gave no warning and no second chances. The final accounting speaks for itself. P-47. Thunderbolts destroyed approximately 3,572 German aircraft in air-to-air combat, more than any other Allied fighter type. They destroyed an additional 3,000-plus aircraft on the ground during strafing attacks. They flew over 546,000 combat sorties in the European and Mediterranean theaters. Their loss rate per sortie was the lowest of any American fighter, 7 aircraft lost per 1,000 sorties. Those numbers represent more than statistics. They represent thousands of young men who went to war, fought against experienced enemies in sophisticated aircraft, and came home alive. They represent German pilots who didn't come home, who died in cockpits of exploding fighters, who learned too late that 850 caliber machine guns could kill faster than reflexes could react. They represent a design philosophy that prioritized pilot survival and overwhelming firepower over elegant efficiency. The story of the P-47's 8 guns is ultimately a story about how wars are won. Not through individual heroics, though there was plenty of that. Not through technological breakthroughs, though the aircraft incorporated many innovations, but through systematic application of superior resources, through industrial capacity translated into combat power, through weapons that worked reliably when everything else was chaos and terror. When German pilots saw the distinctive silhouette of a P-47, when they saw those broad wings with 4 gun ports per side staring at them like the eyes of a predator, they felt fear, not abstract concern, not tactical wariness, visceral fear. The knowledge that if that aircraft got into firing position, 8 guns would pour 100 bullets per second into their aircraft, and nothing in German aviation technology or tactical doctrine could save them from that concentrated fury. The Americans built a fighter that carried 8 machine guns because they could, because their industrial capacity allowed it, because their engineering philosophy embraced overwhelming force over minimal sufficiency. The Germans called it wasteful, inefficient, typically American excess, until those 8 guns started firing. Then the Germans called it deadly. Then they learned to fear it. Then they died by the thousands, blown apart by walls of 50 caliber fire, victims of a simple truth that has governed warfare since the first human picked up a rock. When both sides are brave, when both sides are skilled, when both sides are determined, victory goes to whoever can deliver the most force to the point of contact. The P-47, with its 8 Browning M2 50 caliber machine guns, delivered more force than any other single-engine fighter in the sky. And that force, multiplied across thousands of aircraft, tens of thousands of sorties, millions upon millions of rounds fired in anger, broke the Luftwaffe's back and helped win the air war over Europe. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.